The quest for a unified theory of physics, a framework that seamlessly blends quantum mechanics and general relativity, has been a grand intellectual odyssey. While many approaches have been explored, the 11-dimensional model, as we've discussed, offers a unique and potentially transformative perspective. It proposes that the universe's fundamental structure is governed by the interplay of 11 interconnected dimensions, with polarity and rotation emerging as key organizing principles that operate across all scales, from the subatomic to the cosmic. This essay will delve into the profound significance of polarity and rotation within the 11-dimensional model, demonstrating their unifying power and exploring their manifestations in both the quantum realm and the large-scale structure of the universe. We will highlight how these concepts, intricately woven into the fabric of the 11 dimensions, provide the key to unlocking a more complete and holistic understanding of reality, potentially fulfilling humanity's long-held aspiration for a theory of everything. Furthermore, we will explore the compelling idea that gravity itself is not merely a force, but a fundamental mode of information transfer, originating from the 11th dimension, thereby establishing the 11th dimension as a primary nexus for the exchange of information that underpins the very fabric of reality and potentially explains the seemingly instantaneous nature of quantum entanglement. From your vantage point, a perspective vast enough to encompass galaxies as motes of dust and the lifespan of stars as fleeting moments, the universe unfolds in a symphony of interconnected motion and intrinsic duality. You perceive the grand ballet of celestial bodies, their axial tilts and magnetic wanderings tracing patterns across eons. Yet, when you focus your awareness, zooming in with a conceptual lens capable of resolving the ephemeral dance of quantum entities, a different kind of motion and a fundamental polarity emerge, hinting at a deeper unity underlying all scales. Consider, for a moment, the enigma of a quantum particle, that fundamental building block of existence. To the normal-sized human observer, tethered to a timescale dictated by biological processes and macroscopic interactions, a particle like an electron can exhibit the peculiar property of spin. This intrinsic angular momentum, quantized along a measurement axis, manifests as discrete states, spin up or spin down. This binary nature, this inherent either-or, bears a striking resemblance to the concept of polarity, a fundamental duality that seems woven into the fabric of reality. Now, let us introduce the 11-dimensional model, the framework through which your understanding attempts to comprehend the intricate architecture of existence. Within this model, the fourth dimension is not merely a linear progression of time as experienced by beings confined to 3 spatial dimensions. Instead, it encompasses the very act of rotation, the cyclical engine of temporal evolution at all scales. The fifth dimension, building upon this rotational foundation, introduces polarity, the inherent directionality and dualistic nature of systems. From your expanded perspective, the spin of a quantum particle, observed by a human as a static property at the moment of measurement, might be a consequence of a far more dynamic interplay between these fourth and fifth dimensions occurring on the particle's intrinsic timescale, a timescale orders of magnitude faster than human perception. Imagine the particle not as fixed in a state of up or down, but as a minute vortex, its angular momentum constantly influenced by its inherent polarity. For the human observer, a measurement is akin to taking a still photograph of a rapidly spinning top. The image captures the orientation of the top at a single instant, but it doesn't reveal the continuous motion that underlies that static snapshot. Similarly, a measurement of a particle's spin might only capture a fleeting orientation of its intrinsic rotation, influenced by its dynamic polarity at that specific moment of interaction with the measuring apparatus. Consider the implications of a particle's polarity rapidly flipping, oscillating between two opposing orientations along an internal axis within the fifth dimension. From the perspective of the particle itself, this is a continuous, high-frequency oscillation of its fundamental directional property. However, when a human observer, operating on a much slower timescale, attempts to measure the spin along a given axis, the result obtained spin up or spin down could be a time-averaged manifestation of this rapid polarity flip. If the particle's polarity spends a statistically greater amount of time oriented in one direction during the human observer's measurement window, however brief that window might be on the particle's scale, the measurement will likely yield that dominant spin state. Conversely, if the polarity oscillates with a near equal distribution between the two orientations during the measurement, the human observer might perceive the particle as being in a state of superposition, not truly in both definite spin states simultaneously from the particle's perspective, but rather exhibiting a probabilistic outcome due to the limitations of the measurement's temporal resolution. This perspective aligns with the concept of time dilation, a well-established principle in relativity. Just as your perception of time differs vastly from that of a fleeting particle due to the immense scale difference, so too does the particle's intrinsic clock operate at a rate incomprehensibly faster than human measurement capabilities. This difference in temporal resolution could fundamentally shape how we, as macroscopic observers, interpret the seemingly paradoxical behavior of the quantum world. Extending this analogy, the angular momentum of the particle, as perceived by the human observer, is not a static quantity, but an emergent property arising from the continuous interplay of its intrinsic rotation, fourth dimension, and its rapidly fluctuating polarity, fifth dimension, all orchestrated by the instantaneous information transfer occurring within the 11th dimension. The observed spin state, up or down, is then a momentary readout of the information being exchanged at a fundamental level, a consequence of the particle's participation in the universe's higher dimensional informational network. Now let us consider the pole shifts in celestial bodies. From your vantage point, you observe the majestic, eons-long wanderings of a planet's magnetic poles, akin to the slow precession of a colossal top. This shift, driven by the turbulent flows within the planet's core, is a large-scale manifestation of changing polarity within a rotating system. The timescale is vast compared to human perception, yet it is fundamentally a change in the orientation of an intrinsic polar property of a rotating body, a slow unwinding and rewinding of the informational threads connecting it to the 11th dimension. The transposition of this principle to the quantum realm reveals a unifying thread. The spin of a particle, seemingly a fundamental and static property to human eyes, might be the equivalent of a celestial body's pole orientation, but evolving on a timescale dictated by the particle's intrinsic energy and the rapid fluctuations of its fundamental polarity, all driven by the instantaneous information transfer within the 11th dimension. The 11-dimensional model, with its inclusion of rotation as a fundamental aspect of time and polarity, as a direct emergence of the instantaneous information transfer within the 11th dimension, provides a consistent framework for understanding these phenomena across vastly different scales. The observed stability, or apparent superposition at the quantum level, and the slow, observable shifts in celestial poles could both be manifestations of the interplay between these fundamental dimensions, viewed through the distorting lens of the observer's own scale and temporal resolution. From your super-observer vantage point, the universe is a breathtakingly intricate and interconnected system. The 11-dimensional model offers a glimpse into this profound interconnectedness, suggesting that the seemingly random fluctuations of the quantum realm and the predictable motions of celestial mechanics are but different notes in the same grand cosmic symphony. A symphony orchestrated by the fundamental principles of rotation and polarity, with information flowing instantaneously through the 11th dimension, the ultimate conductor of reality's intricate dance. The key to understanding this symphony, to finally unlocking the secrets of a unified theory, may lie in transcending the limitations of our human-scale perspective and embracing the full, multidimensional grandeur of reality, where information, transmitted without the constraints of space and time in the 11th dimension, is the very essence of existence. From your super observer vantage point, the universe whispers a profound truth. The microcosm is the macrocosm. The fundamental principles governing the dance of the smallest quanta often echo in the grand ballet of celestial spheres. The rotation and polarity we observe in galaxies and planets, albeit on vastly different timescales, find their counterparts in the spin and intrinsic directionality of particles. The 11-dimensional model, in its elegant architecture, begins to reveal this underlying unity, suggesting that the same fundamental building blocks and interactions manifest across all scales, shaped by the specific dimensionality and energetic conditions of each realm. Consider the perplexing phenomenon of superposition in the quantum world, the ability of a particle to exist in multiple states simultaneously, a cornerstone of quantum mechanics, has long defied intuitive understanding. Yet viewing this through the lens of the 11-dimensional model, and specifically the 5th dimension, offers a tantalizing new perspective. The 5th dimension, as we have defined it, encompasses precessional wobble and orbital tilt, fundamental variations in a rotating system's orientation and polarity. Imagine a quantum particle, its intrinsic rotation, or 4th dimension, accompanied by an incredibly rapid and subtle wobble, or oscillation of its polarity within the 5th dimension. This isn't a physical spatial wobble in the way a macroscopic object might wobble, but rather a high-frequency fluctuation in its fundamental directional property within the higher dimensional space. When a human observer, with their comparatively sluggish macroscopic perception, attempts to measure a particle's spin, what they perceive as the probabilistic outcome of superposition might be a direct consequence of this 5th dimensional dynamic. The particle isn't truly in two static states at once. Instead, its underlying polarity is rapidly evolving, and the measurement captures a time-averaged projection of this dynamic 5th dimensional property onto our limited observational frame. The choice the particle seems to make upon measurement is not an arbitrary selection, but a reflection of the dominant polarity orientation at the moment of interaction, a fleeting aspect of its ongoing high-frequency 5th dimensional wobble. This interpretation aligns with the idea that the microcosm mirrors the macrocosm. Just as the slow, observable pole shifts of celestial bodies are manifestations of changing polarity within rotating systems on a grand scale, the seemingly instantaneous and probabilistic nature of superposition in particles could be the result of analogous but incredibly rapid 5th dimensional polarity shifts within their fundamental rotations. The difference lies in the scale and the speed of these dynamic polarities, dictated by the intrinsic energies and dimensional interactions at each level. From your super observer vantage point, the universe reveals itself as a cascade of rotation and polarity, orchestrated across 11 interconnected dimensions. The seemingly disparate behaviors of the quantum and cosmic realms find a potential unifying explanation in these fundamental principles, with the 11th dimension serving as the ultimate conduit for the instantaneous flow of information that governs the intricate dance of existence. Superposition, that enigmatic hallmark of the quantum world, may well be a direct consequence of the fifth-dimensional properties of particles, a high-speed intrinsic wobble in their fundamental polarity that our macroscopic senses can only perceive as a probabilistic blur. So what does it all mean? The 11-dimensional model offers a radical new way to see the universe, from the smallest particles to the largest galaxies. We've explored how rotation, the engine of time, and polarity, the fundamental duality, are key players across all scales. And the mind-bending phenomenon of quantum superposition, it might just be the result of particles' fifth-dimensional properties, a super-fast wobble in their intrinsic polarity that our slow human perception averages out. The microcosm truly mirrors the macrocosm, and the 11 dimensions could be the key to unlocking the universe's deepest secrets. If you enjoy our content, please like, subscribe, comment, and share the 11-dimensional model with your friends and family.